In our last video, we did a quick implementation, or not so quick actually, of a integer linked list. So now in this video, we're going to build a generic one. So we're going to first create our header file. And we're going to call it linked list. I'm calling it linked list instead of just list because I want to differentiate it from the built-in STL type. Okay. And then we're also going to have to create our own node type again. So we're just going to call this node.h now. And because I'm lazy, we're just going to start by copying over our struct. We're going to rename it node. We're going to say it's now a template. T. Right. So now we're going to get rid of all ints. Say here, node next equals null pointer. For X, because we're going to actually have to explicitly define our data type. So now we've converted our node really quickly. Now let's take our node list definition here and grab it, and we can put it in our linked list definition, and then we'll convert it to a generic or templated version. And so here we'll say, oh, let's go back to this one. I want to change one thing first. Our comments. Did we have any in here? No, we didn't. I just rewrote that. Okay. So I've copied this in here. It's going to have to take node.h instead. And we have to convert all these over. And why is it complaining? Oh. I'm going to convert this guy over. Type. Oh, in the last example, by the way, when we want to implement the destructor, the easiest way to do it is to use the clear method we already created, which actually does exactly what we need the destruction to do. Anyway, we'll change this over to say node T. Now, one thing we're also going to do differently is because we're using generics, we are no longer going to do these in a separate file. So, but first I'm just going to modify the definitions. Now, we're making an assumption here that all of our constituent types that we're going to use implement equals. But anyway, so now, because we're doing this in generics, we're not going to do it in a separate implementation file. This is the common practice in C++. So, I'm going to quickly steal stuff from our implementation, because again, I'm lazy. Insert at front. Right, take this guy. In fact, you know what we'll do? We'll encourage my laziness. We'll just take all of this. And we'll clean it up once we copy it in. Now, I'm going to do a quick replace in this file. And we're going to place the scope resolution operator with nothing. Alright, so now we get rid of this. Now we just got to make the changes we need to genericize it. Alright, so here, change this to T, change this to data. Change this. Again, we'll say, we'll change int node, and we will change that here to node of replace all that. So now through here and see what we got here. Data. Notice that for a lot of these implementations, other than changing the node type and the data type, literally nothing changes. And that is the perfect example of a good generic algorithm, is that it's not dependent on the actual type of the data. All right. I think we got just about everything here except to close this guy thing here. Now, just to see, I mean, there's a good chance I missed something there. But let's come over to our run. And we'll create another method called test. Templated list. And here we will now include now change this to what do I call that guy? Oh, let's say int, because we want to replicate what we did the first time. And this to the actual type now. And in theory, the two should produce the same results. First, let's see how it compiles. And it does not. Because I made a typo. And so there's a bug I made throughout. We'll convert that, so I've got to add this back in. Sort of front, sort of back. See if we got them all. Yep. Now, let's do the big thing and see if it actually works. And it worked. They produced identical results. But now we can also come over here to our list and we'll create another test. Just keep it separate. Test template list 2. This time we use a string. And now, in theory, we have changed our code to work with strings. Oops, except that obviously. Oops. Hold on. And here we go. And it works like a charm. So that sees how to convert a strongly typed list to a generic type.